Hello everyone, I welcome you all to today's session wherein we'll be discussing question of CAT level difficulty. So in this video series, if you have been following us for some time now, so you would be knowing that I bring forward questions from different areas. So let's straight away get into the question for today. So the question that I have for you today is this question from the quadrilaterals. Quadrilateral, basically geometry. So what you can do is you can just pause the video right now, try out this question once yourself, right, and see what is the answer that you get, so that you can match your answer with the discussion that we shall be having here. So one of the four options should be the correct answer. See which one for you appears to be the right one. I, however, will be continuing the discussion of the question here. So let's get started. So the question says ABCD is a quadrilateral inscribed in a circle. So what would that mean? I have a circle like this. Now in this circle we have a quadrilateral. So quadrilateral, let's say, is like this. Inscribed in a quadrilateral would mean the four vertices are on the circle. Four vertices of the quadrilateral are on the circle. So this ABCD, BC is given to be 18. Let's say this is B, this is C, this is 18. AC is also given, that is 30, and this is D. AB is twice of CD. So if this is some X, AB will be 2X. AC is also given. So AC is 30. AC is 30. Now this AC is 30. And then he also says AC is the diameter of the circle. See, the moment a chord becomes the diameter. So if AB is the diameter, let's say. Now there are several things that will follow now. Right? For example, one of the points is this is going to be radius, this is going to be radius. So diameter is 2r. That's a commonly known fact. Now, one more thing is, if AB is the diameter, then we have a property in circles which is angle formed in a semicircle is always 90 degree, is always right angle. So that means if I take any point here, say point X, point Y, point Z, point B, any point that I take, if I connect these points, individual points with both A and B, I'll get angles like this. Each of this angle, this angle, this angle, each of this angle is right angle, 90 degree. So that's the property that we have in case of circle. So the property is angle in a semicircle is 90 degree. So if, since AC is the diameter here, so can I say this angle ABC is going to be 90 degree. So the moment it is 90 degree, we can apply Pythagoras theorem. That would mean what? AC square will be equal to AB square plus BC square. AC square is 30 square. AB is 2x. So 2x whole square is, I'm writing it directly, 4x square plus BC square is 18 square. So 4x square, let's bring all the terms on one side, 30 square minus 18 square. So this is what? This is 900 minus 324. So this is going to be 576. So I'll write it here, 4x square will be equal to 576. So when you solve this, 4 will go 144 times and x will turn out to be root 144, which is 12. So this length here is going to be 12 units. So this is 12. So this is going to be 24 then. Okay, twice of x, 24. Now look at the question. He's asking me to find AD. He's asking me to find AD here. So for finding AD, what we could do is, again, this angle here is going to be right angle triangle, angle ADC. Again, apply Pythagoras there. So when you apply Pythagoras theorem there, we get AC square will be equal to, that will be equal to AD square plus CD square. So what is AC square? 30 square, 900. AD square, that is what we have to find out, plus CD square, 12 square, 144. So we'll get AD as root 756. Root 756. So what can we take out common? Let's look at it. So if we take out 6 into 12, 126, 126. So we can take out 36 common. So root 36, 36 goes 21 times. So root 36 is 6, root 21 is what should be our answer. So this is going to be our answer, right? So this is how option choice B will end up being our answer. I hope we are clear with this working. Just a small thought here. There could be one more way in which I could have thought about this problem. And that is again just extension of these two steps, or basically combining these two steps together. See, we already said that in the triangle ABC, AC square is nothing but AB square plus BC square. Again, AC square in the second triangle is nothing but AD square plus CD square. So the moment I know the value of this x by using the Pythagoras theorem in the first, I can directly get AD square now as AB square is known. However, it's one and the same thing only, right? Not very different. But this could be another way of looking at it, right? For example, imagine if in this particular quadrilateral, these lengths were given to us. This is 12, 24, 18 given to us, right? AC is the right angle, AC is the diameter here, that is also given to us. Then he's asking us to find AD. Okay, AC is the right angle, AC is the diameter is given, and these side lengths are given. This is given, this is given, this is given. He's asking us to find this. So we can go for that also. We can use Pythagoras theorem. We can say simply this square plus this square should be equal to this number square plus this number square. That way directly we can get to the value of this missing side. So I hope we are clear with this additional point I was trying to explain here. Right? So just to repeat, what I'm trying to say is, if AC is the diameter, this point is given, not 30. 30 might not be given to us. Right? These side lengths are given. This is given. Now he's asking us for this. So here we can say this square plus this square will be equal to this question mark square plus this 12 square. We can still find the value of this question. Alright, I hope you are clear with this. So with this we have come to the end of today's session. On that note, let me end it here. Right. So I hope you followed it. Thank you and all the very best.